Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial, and we have specific processes under specific results. Then we end it. Let's start with this polynomial. This time, our quadratic trinomial has coefficient for its first term no longer equal to 1. Still, we're going to factor this, and for that we're going to verify first whether this is a perfect square or a perfect square trinomial or not. So the conditions for a perfect square trinomial must be met first in order for us to use that, and if these two conditions will not be met, then let's proceed to the second method. The first condition is this. The first term must be a perfect square expression, and the third term must also be a perfect square expression. Here, looking at our coefficients here, our x is a perfect, x squared is a perfect square of x, but 2 is not a perfect square. Well, we could also again argue that we could say, what if we take square root of 2 and square it? This would satisfy that 2 is a perfect square. Okay, so if that is the case, okay, let's try to consider that. And the third term is also be treated like this. What if it's a perfect square of square root of 3, which gives us a result of 3? This might say that 3 is also a perfect square of radical expressions just like 2. However, it is with minus sign. So in this case, the first condition is no longer possible because you can only get a negative constant that is already a perfect square with imaginary numbers as its root and not a real number. So since the first condition is not met, let's not move further to the second condition. This is automatically a non-perfect square trinomial. And with that, let's use the second method of factoring. AC way or the AC method. AC way or AC method allows us to multiply A and C coefficients. The A coefficient is the coefficient or geometrical coefficient of the first term. You will have 2. And your C is your constant. It's not 3. It's negative 3. So AC is 2 times negative 3. You will have negative 6. Let's look for factors of negative 6. So we have 1 and negative 6. You can also try 2 and negative 3 as given earlier. You could also try negative 1 and positive 6 and negative 2 and positive 3. The AC way method, aside from this, collects these pairs, and let's try to add all of this. If there's a pair that will result to our second coefficient, the coefficient of your x, this means that our polynomial is factorable and we can proceed further. If none of these 4 pairs can satisfy the middle term, then our given is already in the simplest form in terms of factoring and we can no longer factor it. But when you look closely, the first pair of coefficients, 1 times negative 6 will result to negative 6, but when added, they will result to negative 5. This means this is really factorable. And how do we factor that? Let's do it like this. By the way, there are a lot of processes that will include here, but I'm just going to give you a version of mine, okay? Usually, we will just try to put it like this, okay? The square root of the first term is x. Let's just try the x and x. But when you multiply x times x, it will not return to 2x squared. So we still have 2. So one of which is we're going to place 2 here, right? Then if we're going to place these coefficients plus 1 and minus 6 here, there is something wrong still in our process because when you use the FOIL method, just simply look at the product of the last terms. 1 times negative 6, it's not negative 3. So here's my suggestion. Okay? After you're done getting the identified coefficients that will satisfy the condition of AC method, let's just try to put 2x in this case and 2x here. Don't worry that when you multiply it, it will result to 4x squared because later there's something that should be done as still. So you have 2x and 2x, and you place now the coefficients plus 1 and negative 6 here. Take note, again, when you use the FOIL method, it will not return to our original polynomial, but a version of our original polynomial. What we could do here is look at this. We have 2 and 6. There is a greatest common factor of the coefficients, which is 2. So in this case, I'm just going to copy this first because there's the greatest common factor of 2 and 1 is just 1. So I have here 2x plus 1. And what happens to your second binomial is you divide both terms by 2. So you will have here x minus 3. When you multiply this using the FOIL method, 2x times x, 2x squared, we have 1 times x is positive x, 2x times negative 3 is minus 6, so 1 minus 6 is minus 5x, and 1 times negative 3 is negative 3. These are now the final factors of 2x squared minus 5x minus 3. Using the AC way, because we have not satisfied the condition of perfect square trinomial, we use AC way, and we use this technique that I have mentioned a while ago. This returns to the original polynomial when these two binomial expressions are multiplied with each other. The next factor we're looking for is for our next subscriber. Subscribe now!